We talked a little bit about z-score yesterday, so we're going to go back and look at it a little bit more today. All right. So to get the z-score, you got to have three things. You've got to have the observed actual data value. Well, what are you talking about when I say that? You got to have like your test score. So if you have your test score, then you compare it to the mean. All right. That's the second thing we need. We need to know the mean. So we're going to take your test score, then the mean, and then we're going to divide it by the standard deviation. That's how we get our z-score. All right. Z-score is, again, how many standard deviations above or below the mean. Positive, we're above the mean. Negative, we're below the mean. Okay. Now, the thing we're going to discuss today is we're going to talk about inverse normal distribution. All right. So inverse normal. So I need you to find this little spot. It's kind of where we left off from yesterday. All right, we did the potato chips, and then I think it's the very next problem there. Okay? I'll give you a chance to find that there. All right, so sometimes we need to find either an x or a z that's going to correspond to the area underneath the normal curve. For instance, if I wanted to score like the 90th percentile on the PSAT or whatever, what score am I going to have to make? All right, that's what we're looking at today. So I want to score in this percentile. What do I have to score on that to get that to be an option? All right. So here's what we have. Given that z, the random variable z, is normally distributed with a mean of 0 and a standard deviation, that's actually the variance of 1. If you took the square root of it, it'd still be 1. So standard deviation of 1. Find that this is true. So we're going to draw a curve to help us with this. So it says this: the probability that the variable that I have is less than a, all right, is 0.877. So I'm the 87.7 percentile. All right. Where would I put a value on here? Where would I put a on here so that 87.7% of it is less than that value? I wouldn't put it in the middle because what's in the middle? It's 50 either way. Correct? So where would I put it compared to the mean? All right, where would I put it compared to mean so that 87.7 is less than it? Somewhere on the right side. So this is where A is going to go. Because everything less than A needs to be 87.7%. That's quite a bit of the data. All right, everybody okay with my picture? So now here's where I'm going to go. I'm going to go to my calculator to go help me to find this. So if I go to my calculator, I'm going to go on and new. I'm going to start fresh in this class. I'm just going to go add a calculator. The spot that we've been the last couple days is in menu, and it's either probability or statistics, and we're going to distributions. Either way you want to get there. Yesterday we talked about number 2, which was normal CDF. Today you see it, it's number 3, it's inverse normal. So when I go to inverse normal, it asks me this: what's the area? What's the mean? What's the standard deviation? Does that mean that standard deviation match the problem? Yeah. That's what we have. What is the area? The area is that 0.77. Okay? Excuse me, the 0.877. Thank you. 0.877 is what I'm going to put in for that. I hit enter, and it spits that back to me. So 1.16 is where I need to place this value. 1.16 is that A value for question A. All right. Now, here's what else this means. That right there, that is my z-score. All right. That's my z-score. It's standardized. It's a 0 is the mean. 1 is the standard deviation. This is the z-score. If I wanted to score in the 87.7 percentile, everybody that scores in the 87.7 percentile would have a z-score of 1.16. It does not matter the test. All right? If it's a harder test and you score in the 87.7 percentile, remember Sue and James yesterday that we changed those. And we found the z-scores for them. Everybody in that percentile would score that. Okay? Go to the next one. How is it different? It's greater than. All right? So again, this is the mean. All right? If I'm saying that I'm greater than A, and the probability of being greater than A is 0.2. How much is 0.2? Not a lot, all right? But I want to be greater than a value and I want to be in not a lot. Where would my A fall here? To the left side or the right side of the mean? It'd be on the right again. All right? This is the 0.2. All right? So 20% or greater than that. That's not a whole lot. So the A is going to be over there. The A should be positive. It should be better than the mean. Bigger than the mean. Good? So I'm going to put that in my calculator. If I go to my calculator and do that again, so I go menu, and I go probability, distributions, and I'm going to go inverse normal. What's the area that I'm going to put in? 0.2. And when I do that, it gives me this. Thoughts? It can't be negative, right? Because where were we? We're supposed to be bigger than the mean, right? So the mean is 0. We should be positive. So what's taking place here? Well, here's how the calculator is working. The calculator, whenever you give it the area, it's always going to use that as less than. All right? So what the calculator just did is it really just said this was 0.2, and it went and found me this. All right? It found that A value. So it found negative 0.8416. Well, knowing what I know about normal distribution, what could I do? Just make it positive. It's symmetric, right? So I know that should be a positive. So my answer is 0.8416. It's the positive part of that. Now, how can I get it done correctly in the calculator? Well, 20% are better than it, but this is figuring percentiles. What percentile would that be? How many of them are less than A? 80. 20% are bigger than 80. 80% are less than 80. I need to always put the less than one in the calculator. All right? Or I'm going to have to flip the sign. Either way you want to do that. So if I were to go back to my calculator and do the same thing, all right? If I go over here, I'm just going to go highlight it. I'm going to go change the 0.2 to be 0.8. Get the same exact value, but now I get the positive one. All right? So understand this. Whatever area, whatever probability that you give the calculator, it's always going to work less than that area. All right? That's how it's going to work. Good? All right, so let's take a look at the last one here on this page. By the way, I'm finding what I need to make on this to score in this percentile. So I got to have a z-score of 0.8416. All right? What's a little bit different about this drawing here? Where does this area go? What's it tell me here? How many A values I have? I have two. I have a positive and a negative, but they're the same value, correct? So is it symmetric? It is symmetric, all right? So if I did this, if that's my mean, then I have A here and I have negative A there, and in the middle of this is 0.42. So that's the picture that I've given, all right? Can I put 0.42 in my calculator? No, because this is not the 42nd percentile. It's the middle, and it's the numbers in the middle. So I need to have something that's going to go all the way to the left. So how do I do that? What could I do here to find that?
You could do the inverse of A minus the inverse of negative A. So it'll give you everything to the left.
But yeah, but what area? I see what you're saying. What area am I going to put in there? Because I can't put 42 is not going to be the right area. If I put 42 in my calculator, it's going to find this right here. It's going to find that right there. That's got 42 right there. That's what it's going to find. Split in half. So if I split this in half, this would be 21 and 21. Is that what you're talking about?
Oh, we're finding what's in between it?
Mm-hmm.
Oh, okay.
Well, that's how this is written. The 42 is in between.
Gotcha.
But I'm wanting to know what these values are. So if I split that 21 and 21, really the value that I need is this value right here. What is this value? How much area is sitting right here on the left-hand side of this? How much area is on the left-hand side of that blue line? 50 minus 21 28. Sitting right there. Excuse me, 29. I wrote 29 and said 28. It's 29 that's sitting right there. Yes, sir.
How do you know that negative A and A are directly in line with the middle?
Because if I have A and I have negative A, then I'm symmetric. I want a certain, I know the
Oh,
middle is
'cause
0.
It's the same variable.
It's the same variable, okay? Now, if I had X and negative Y,
Right.
then I'd have some trouble with this
Okay,
one,
that
all
makes
right?
sense.
All right, but because they're the same, I could do that. Good? So what number am I gonna put into the calculator? 29 is one thing. If I put 29 in the calculator, what value is it gonna give me, A or negative A? It's gonna give me negative A. So if I go to my calculator and I do that, I go menu, and I go probability, and I go distribution, and I were to put inverse normal, and I put 0.29 in there, then that right there is the value of negative A. What's the value of positive A? Just the positive version of that, correct? So 0.553 is A. That's what I'd say A is. Negative A would be negative 0.553, okay? Is there a way that I could have found A directly? What area would I put in to get A directly?
All of it?
How much is all that? 42 plus the 29 is 71. So A is the 71 percentile. Negative A would be the 29th percentile, and I could use either one of those to get what A is. Everybody okay with that? You do not have to do all of that. When you look at this problem, some of us look at this problem differently. It's fine. Some of us may have looked at this problem and gone, well, if there's 42 in the middle, then 1 minus 42 is 58, then I'm splitting on the outside. I could go 58 divided by 2 and get 29 that way. That's fine also, all right? So there's a lot of different ways that we could look at this, all right, as you're going. Everybody okay so far? All right, so where's the context of this? What can we do this? What kind of word problem can we use this in? All right, so let's take a look here. This next one, let's say like the Switch 2 just came out not too long ago, right? It's fairly new. Is that the newest one on the market right now? All right, something like that. Anybody? There's not a new one I don't think right now. And so let's say I'm the maker of that. If I'm Nintendo, I'm making that Switch, and the mean lifetime of the product is 30 months. How long is 30 months? It's less than 3 years. It's what? It's 2.5 is what it is.
It only lasts
24. 24 would be 2 years, and then 6 months, so that'd be 2.5 years. So the mean lifetime of it is 2.5 years, is what I'm saying. With the standard deviation of 4 months, suppose that the lifetime is normally distributed, so it follows this curve. So if it's normally distributed, could I draw a sketch of this?
Yes.
If I have a sketch, what would go here? 30 months would go there. This would be 34, this would be 26. How many of the consoles last from 26 to 34 months? 68% of the data, that's that big number that we've been talking about. 68% of the data there. If I win another one, I could go up another 4 to 38 and down another 34 to 22. How many of the consoles last between 22 and 38 months? 95%, that's correct. All right, 95% there. Now, here's what I'm worried about. As the maker of Nintendo, I'm worried that if I have a bad one and it goes out early, I don't want to get any bad comments or bad publicity or whatever, so I'm going to refund the money for anything for 7%. I'm budgeting for 7%. All right, where does that 7% go? Who am I going to refund? That don't have it very long, right? So this right here, I'm going to put a value of X somewhere in there, and less than X is 0.7%. Am I worried about the people over here?
Oh, they're doing great.
No, congratulations, you take care of your stuff, you're good. I'm not going to refund you for doing a good job, sorry. I'm going to only refund you if my product doesn't work, okay? So now, I want to go find what this X is. So I know what's my mark. Where am I going to set my warranty or whatever? So I'm going to refund at this mark. If you haven't fallen into that, then I'm not going to refund. So now this is an inverse normal situation. So if I were to go to my calculator, what's the area that I'm going to put in my calculator? The 0.07. That's correct. All right. So inverse normal. By the way, anytime that they give me area or anytime that they give me probability, I'm going inverse normal because that's what area means. It's the probability. So 0.07 goes there. This one's a little bit different. What's my mean? We're no longer at 0. We're now at 30, and my standard deviation is 4. So I hit enter, and it tells me that that X should be placed at 24.1. All right, 24.1 months. I don't know if I'd count 0.1 a month. I'd probably be okay with 24 months. So basically what I'm saying is this: if your system doesn't last longer than 2 years, then I'll refund you. All right, but if it goes crazy before 2 years, then or if it goes crazy after 2 years, then I'm not going to refund you. Okay, good on that one? All right. Got a couple other problems that I want to show you real quick, but they're not in your packet. So you can add them on, or you can find a little spot in your notes. I'm going to give you just a little bit of time. I want you to read this one real quick, and then we're going to discuss it.
The game even at the game on ring together. Except the game last night.
All right. Here's what I'd like for you to do. Now that you've read it, I want you to draw me a quick little sketch of it real quick. Draw your normal curve. By the way, how do we know it's normal? Because it says it, right? So on a normal distribution problem, it's going to state that in there, all right?
On the test, are they all going to be normal?
They're not all going to be normal.
So-
But if it's a normal one, it should state that it's normal in there.
So
Okay.
if it's not, we'll know that it's not.
It kind of gives me a clue that it's something different, yeah. Okay? So I have this. What goes here? 5 goes there. What else do I have in this one?
But 10% were over 5.2.
So I have 5.2, and there's 10% right here. So there's 10% that are greater than 5.2. Okay, so basically the 5.2 is the 90th percentile. Yeah, we could say it that way. Okay, so 5.2 is the 90th percentile. Everybody okay with the drawing? It asked me to find the standard deviation. Now, here's where we have to go with this. To find standard deviation, we're going to use our formula for z-score that we discussed yesterday. Okay? So we're going to use our z-score formula to help us to solve this. Now, I told you a while ago that anytime something is in the 90th percentile, it always has the same z-score. Doesn't matter if we're talking about production. It doesn't matter if we're talking about the PSAT or SAT or ACT or whatever test. If you score in the 90th percentile, those people always have the same exact z-score. Okay? Now, here's the problem with this question. If I were to go to my calculator, I'm going, okay, I'm not really sure where to go, so I'm going to go to my calculator. I'm going to go put it in the calculator. All right? If I were to go to normal CDF, like we talked about yesterday, what do I have to plug in here? Upper bound, lower bound, mean, and standard deviation. But what don't we have? Standard deviation. So I can't use that one. All right? If I were to go to the other one, menu, probability, distributions, and I go to inverse normal, I need the area and I need mean, but I also need standard deviation. So I'm kind of stuck. All right? Now this is where I'm going to stay on this one. What is my area? 0.1. Actually, I'm going to use the other side of it. So 0.9. So it's the 90th percentile. Now, by the way, if you want to, You could go 1 minus 0.1 if you don't want to figure out what it is. The 0.9 is easy on this one, but some of them may be a little bit more defined. You could just go 1 minus that, all right? Now, if I do this, you're going, well, the mean's not 0 and the standard deviation is not 1, but no, we're standardizing it. That is my z-score, all right? So we're going to bring it all to the same value. So if I were to do this right here, then what I just got right here, 1.282, that is my z-score. That is the z-score for anything in the 90th percentile. All right? So I'm going to take that z-score, 1.282 equals, what's the mean? 5. So minus 5. This x represents that 5.2, and I don't know the standard deviation. Everybody okay with the way that I've set that up? This is kind of the tricky part in this unit. Now, how do I solve that? Yeah, multiply each side by the standard deviation. For sure. So multiply by standard deviation, so that cancels it here, multiply it over here. So 1.282 times the standard deviation equals 5.2 minus 5 is 0.2. And I'm going to divide by the 1.282. Definitely a calculator problem. Right? So if I go to my calculator and I go 0.2 divided by, I'm going to go up and highlight that z-score. So I got a standard deviation of 0.156. Now, once you get the standard deviation, could you do a lot more things in this problem now? Now it opens up the doors to be able to use anything, and they can ask all kind of questions, whatever you're good from there. Okay? Good? Let's try one more like this. Yes, sir?
I don't understand how you got the z-score without using the formula.
The z-score is always standardizing the data on a 0 mean and a 1 standard deviation. All right? So you take anything that you want, if you standardize it and make it 0 and 1, if you have a 90th percentile that we have right here, everything in the 90th percentile is going to have that z-score of 1.218.
So did that only work because it was 90th percentile?
Well, whatever the percentile that I have is, so each percentile has its unique z-score that matches with it. Okay? So I don't care what percentile you're in. You could score, we could all score in the same percentile on whatever test, but we'd all have the same z-score. Okay, for whatever that percentile is. Okay? All right. Take a look at this last one. This last one we're going to do today, and then I was going to work a little bit of homework with you as well. All right, so we'll kind of guide you through some homework. Again, I'm sorry this one's not in your notes, so we're just supplementing a little bit here as we're going. Okay. Now, this is probably the hardest problem in this entire unit right here. Okay, this is the most difficult one, I think. Just got a couple little steps to it. All right. If I was going to sketch this, by the way, this manufacturer does not know the mean or the standard deviation for the diameters of the ball bearings that they're producing. However, they have a sieving system, rejects all ball bearings that are greater than 2.4 and less than 1.8. You ever seen those little coin banks or whatever that you put your coins in and it like sorts them for you? Like you put a quarter in it, drops it over here, a penny. That's what's happening right here. All right, so they're sorting out these ball bearings. So if I was to do normal distribution, because it says that right here that they're normally distributed, if it's 1.8, it's going to reject them. If it's less than 1.8, it's going to reject them. If it's greater than 2.4, it's going to reject them. All right. What's the probability that I reject because they're too small? 8%. So I'm going to put 0.08, 8%. What's the probability that they're going to reject these? 0.055 or 5.5%. Okay. So there's my model. Could you tell me the mean? No. what if they were 8% on both sides?
Yes.
Then it would be in the middle, correct? So if it's the same, then I could do it. But because they're different values, I don't really know where the mean is. All right, so I'm gonna have to use something else. And I don't know my standard deviation either. So what I'm gonna do is I'm gonna use my z-score formula twice, one for the left-hand side, one for the right-hand side. Okay? So if I were to do this, I'm gonna go, I'm gonna put the 0.08 into my calculator. So that's the 8th percentile. It's not very good. All right. So what is the z-score for an 8th percentile? So go menu, and I'm gonna go probability, I'm gonna go distributions, and I'm gonna go normal, and I'm gonna put 0.08 in there. So I'm gonna find my z-score for the left-hand side. So the z-score for the left-hand side is negative 1.405. So negative 1.405. The x is 1.8. The mean I do not know, and the standard deviation I do not know. So there's 4 variables. I know 2 of the 4. Okay? Questions about that equation so far? All right. Now I'm going to go do the same thing on the right-hand side. I'm going to get another equation. All right. It's going to be 2.4 minus mean over standard deviation, but I'm going to have to go find that z-score. Okay. So if I'm finding that z-score, I'm going to go to my menu, and I'm going to go probability or statistics. I'm going to go distribution. I'm going inverse normal. Now, I'm going to use 1 minus 0.055. I'm going to do it that way. You could already subtract it and put, 0.945 in there? 945, all right? Or you can just do it like this, okay? Sometimes I just want to be lazy and do it that way. So my z-score on the other side is 1.598. What I've just done right here, I think, is the hardest part of this problem. Questions about how we got there? Okay? Now, I have 2 things missing, correct? I have mean and I have standard deviation missing. So if I have 2 things missing, it's a system of equations. I need 2 equations to work with this. Now, I'm going to show you 2 different ways we could solve this. I don't care which way you do this. But one thing that I would probably do is I would multiply by the standard deviation on both sides. So if I were to do that, I get negative 1.405 standard deviation equals 1.8 minus the mean, or, and on the other side, 1.598 standard deviation equals 2.4 minus the mean. And I would divide by this number out front. I'm doing that because it allowed me to get a variable by itself. Okay, so I have a variable by itself. So I got standard deviation equals all that over there. So if I go to my calculator now, I could go control doc, and I could add a page, and I could add a graph. So it's standard deviation, which I'm saying is the y value, and it's control division, and it was 1.8 minus x over negative 1.405. So I just changed the variables, all I did, put them in the calculator, all right? So there was that one. I hit tab again, and I can say the other one was 2.4 minus x over the 1.598. They intersect, all right? And the place that they intersect, I'm gonna go analyze, intersection. And so they intersect at 2.08 and 0.2. What's the 2.08 stand for? What's the x in this problem? The mean. 2.08 is the mean. The 0.2 is the standard deviation. Okay? Other thing you could have done is you could have just gone to menu. You could have gone to the algebra and solve a system of linear equations. Hit OK, and this equation right here was negative from the very beginning, 1.405 equals control division 1.8 minus x over y. And this one was 1.598 equals control division 2.4 minus x over y. You could have done that. That's from the very beginning. Hit enter. Didn't like that, huh?
Seems like it doesn't work.
That's fine, then I would do it this way. I got a way to run it. It doesn't like the fractions, is what it doesn't like. And so, I could do the first step that I did. And don't put the y down here.
The Y with that.
Put the y over here. Same thing here. Put the y there, put the y over here. That's like after we multiply by standard deviation. Then we got it. Okay? That way may be a little bit better way, because what do you notice about the answers?
It's way more.
They're a little bit more exact, right? So I can get them better. Okay? All right. So let's do this. Let's go to page 615. This is the first page of the homework. Doing 3 pages homework. 615, 616, and 619. Okay? 615, 616, 619. All right. So I'm going to kind of walk you through some of this real quick. That'll help you along with this one. All right? Let me see if I can get this just so slightly. All right. This first one, it says that the probability Z is less than A is equal to, this is 615, less than 0.922. Where's this A going to be related compared to the mean? If 92.2% or less than it. It's going to be to the right. Pretty good ways over here to the right, correct? Because all this right here is 0.922. So what am I putting into the calculator? Okay.
Just go and bring stuff. 10 minutes, just this.
What area am I putting into the calculator? The 0.922. So this one's pretty easy to find. Gonna go inverse normal, put it in the calculator, got it, and I'm done. All right?
Put it in the calculator.
615. All right? Next one. How much of a percent is this? About 30%, about a third of it, right? About a third of the graph. Where is it? Greater than A. So I want a third of the graph to be greater than A. So if that's the mean, then I would say A would probably be about right there. There's a third of the graph. Okay? So there's the picture for that one. What would I put in my calculator for area? 1 minus that. If you put the 0.342 in there, what's it going to give me? It's going to give me the negative value of it, and I'm going to have to change it to the positive. So by sketching these out real quick, it kind of helps me to know I could still get the right answer by putting the wrong thing in the calculator, just as long as I know where it belongs. Does that make sense? All right. Same thing on this one. I'm not going to do C, but it's the same as what we just did there. All right. Now, I need to show you a little bit of 2. So, if I were to do 2, this is 0, this is 1, this is A. And on 2A, it says that the area between 1 and A is 0.12. So this area right there is 0.12. I want to know the value for A. Okay. How do I do this one? Any thoughts? Okay. So this has got a z-score of 1. So if we're thinking about our rules, alright? That's 34. Why? Cause 68 cut in half is 34 for that one. So 34 there and 50 over here. So how much is less than A? 96, that's correct. So I'm gonna put the 50, the 34, and the 12 all together. So everything less than A, so A is actually the 96th percentile. It didn't tell me that up front. I just had to do a little bit of work to find that area, all right? But 96 is the number that I'm gonna use in my calculator. Okay? Everybody all right with that?
Wouldn't you have to subtract anything off of that afterwards?
Now, that's gonna be it, all right? Cause I'm looking for, the number I gotta put in my calculator is whatever that A value is that I'm trying to place, I want all the area to the left of it, okay? Now, 2B is a little bit different. So on 2B, I have A and I have 1.6. So 1.6 is gonna be over here, it's gonna be on the positive side. I would guess that A would be over here on the negative side. Why would I make that assumption?
Because it's the least.
It's the smallest of the two, correct? And how much area is in between them?
A lot.
78.7% of the graph. That's a lot of the graph, correct? So I'm thinking it's gotta be over there pretty far right, okay? So this right here, this area is 0.787. Now, I'm only wanting to find A. I'm only wanting to find this area. That's all the area that I need to find A. How do I do that? I got a thought on this one. Got to use a little bit of yesterday and a little bit of today. All right. I'm gonna find all the area less than 1.6. How do I do that? Well, I'm gonna go to my calculator. And I know it's hard to see up there because I got some of the writing up there. I'm gonna go to menu, I'm gonna go to probability, I'm gonna go distributions, but I'm gonna use normal CDF. So if I want everything less than 1.6, negative 9, E99 is my lower boundary. 1.6 is my upper boundary. 0 and 1 are my mean and my standard deviation. So all the value less than that is 94.5%. But I have that middle little section of minus 0.787 that I'm going to take out. And so I got 0.158 left over. So on here, what we did is all of this less than that was 0.945. We took this part out right here, and we got 0.158. So that's the area that's less than A. That's the area that I'm gonna put in my inverse normal now. So I'm using a mixture of the 2 days there. Okay? Questions on that one? Yes, sir.
I'm kind of confused what normal CDF and inverse normal, like what's the difference between those two?
So normal CDF is I'm going to find the area. I'm going to find the probability. So I'm gonna give you the bounds. I'm gonna give you the upper bound, the lower bound, all right? And I'm going to find the area. I'm going to find the probability, okay? Inverse normal, I'm giving you the probability and you're going to find the bounds. But we're not really finding 2 bounds, we're just finding 1 because the calculator is always gonna use the lower bound as negative infinity. So we're treating the lower bound as negative infinity. You're telling me wherever the bound is and you know the probability and we're placing the bound, okay? So that's the difference between the 2, all right? One of them's giving me probability or area, one of them already been given probability or area, and it's finding the other, okay? So we're kind of going back and forth there. All right. We've got about 2 minutes remaining.